Hi everyone, in this video I want to solve some exercises that I gave you before as homeworks from chapter 9. Let's start with exercise 1. 25 high school students complete a preparation program for taking the SAT test. Here are the SAT scores from the 25 students who completed the SAT preparation program. We know that the population average for SAT scores is 550 with a standard deviation of 100. You can see that the standard deviation of population is known here. The question is, are these students' SAT scores significantly less than a population mean of 550? So, the first keyword is the mean. So the hypothesis test is about mean. And another keyword is less than 550. So the question is about mean and less than 550. So in the first step we need to formulate H0 and HA. So step 1, H0 and HA. So mu is less than 550 and mu is equal to 550. In step 2 we need to calculate test statistics, but we should need what we have from the question. We know that n, the sample size, is 25. The standard deviation of population is known, is equal to 100. So sigma is known, equal to 100. It shows that we have case 1. And we need, according to the test statistics, we need x bar. X bar minus mu 0 divided by sigma divided by square root of n. So we need to calculate x bar from these 25 values. So from 434 to 531, you need to obtain the summation of these values divided by n. So x bar, the result is 536. So 536, mu 0 is 550, sigma is 100 and divided by 5, and the result is minus 0.7. We have a left tail test. Now look at this slide. So we need to find a critical values from the Z table. Z alpha. Alpha is equal to 0.05. So in step 3, alpha is 0.05 and we need Z alpha is 1.645. And in step 4 we need to make the final decision. We have a left tail test, so the rejection region is minus 1.64 the critical values is, and the test statistic values is here. So fail to reject H0. If you look at the rejection region, you can see that the rejection region is the Z less than or equal to minus Z alpha. So also we can write the rejection region as Z equal or less than minus 1.645. This is the rejection region. And this value is the value of test statistics. In part B, what is the type 2 errors for mu prime equal to 540? So if you look at the formula for type 2 errors, you can see that we have a left tail test, so we need to obtain these values by using this formula or equation. So for part B, we need to calculate type 2 errors for mu prime equal to 540, and the formula is 1 minus SA divided by sigma divided by a square root of n. So is 1 minus Z alpha, it means Z for 0.05 is 1 minus 645. We had it before. Mu 0 is 550. Mu prime is 540. Sigma is 100. N is 25. So the result is 1 minus 1, 4, 5, and according to the normal table is 1261, and the final answer is 0.8739. In part C, what value of n is necessary to ensure that beta, the type 2 errors for mu prime equal to 540 is equal to 0.05? So again, look at the formula. For a one tail test, we have a left tail test. This is the formula. So for part C, beta for 540 should be equal to 0.05. So n is sigma z alpha plus z beta divided by mu 0 minus mu prime power 2. So sigma is 100, z alpha is z 0.05 is 1.645, z beta, again beta is equal to 0.5, so is z0 0.5 is 1.645. So 1.645 plus 1.645 divided by 550 minus 540 power 2, and the result is 1082.41. It means approximately we need 1083 samples. Okay, exercise 2. Principal at a school claims that average of IQ scores for students in his school is 100. So he claims that the average of IQ school average. Again, we have a keywords here. The hypothesis test is about the average. The average is 100. It means equal to 100 or it's not equal to 100. We have a two-tailed test here. A random sample of 49 students scores have a mean score of 95. The population standard deviation is 14. Again, the population standard deviation or the population variance is known. We have we have the case 1 hypothesis test for population mean. So is there sufficient evidence to support the principal claim? So the first step is writing H0 and HA. So mu is equal to 100 or mu is not equal to 100. We have a two-tailed test. Step 2, we need to calculate the Z statistics. So according to the question, n is equal to 49 students. So sample size is 49. And the students score have a mean score of 95. The sample mean is 95. And the population standard deviation is 14. So sigma is known here again. It shows that we have case 1. So Z is equal to x bar minus mu 0 divided by sigma divided by a square root of n. So x bar is 95, mu 0 is 100, sigma is 14, n is 49. So the result is minus 2.5. In step 3, we need a critical values from the normal table. Alpha is 0.05, sorry, alpha is 0.05. So we have a two-tailed test, so we need alpha divided by 2 is 0.025. So Z for 0.025 is 1.96. In step 4, sorry, we need to make the final decision. So we need to show the rejection region. We have a two-tailed test, 1.96 minus 1.96. So this is the rejection region, and the test statistics value is minus 2.5. So it's here, minus 2.5. So the result is rejecting H0. Again, part B, what is the type 2 errors for mu prime equal to 95? We have a two-tailed test. If you look at the formula for two-tailed test, the type 2 errors, to calculate type 2 errors, we need to use this formula. Here they are the same. Here we just have Z alpha divided by 2. Here is minus Z alpha divided by 2. So for part B, we want to calculate beta for 98. So we need Z alpha divided by 2 is 1.96 plus, okay, if you look at the formula, mu 0 minus mu prime, mu 0 is 100, mu prime is 98, divided by sigma is 14 and n is 49. Again, you need to write the same values. Here we just should add a negative sign. So minus 1.96 plus 100 minus 98, 14 divided by 7. So here we have 2.96 minus, and here is minus 0.96. By using the Z table, we have 9985 minus 1685, and the result is 0.83. And in part C, what value of n is necessary? What value of n is necessary to ensure that beta 98 is equal to 0.1? So again, if you look at the formula here, for two-tailed test, sigma Z alpha divided by 2 plus Z beta, and then divided by mu 0 minus mu prime power 2. So n is equal to Z alpha دوم plus Z beta divided by mu 0 minus mu prime. Here we have sigma power 2. So alpha is 0.05 and beta is 0.1 because we want to beta for 98 equal to 0.1. So beta is 0.1 and mu prime is 98. Mu 0 is 100. So n is equal to alpha divided by 2 is 0.025 and Z for 0.025 is 1.96. Beta is 0.01 and Z for 0.01 is 1.28. Sigma is 14. Mu 0 is 100 and mu prime is 98 power 2. And the result is 514.38. So approximately we need 550 sample, 15 sample. Exercise 3. According to CNN, in 2011, in average, American spends 16,803 on housing. Suburban community wants to know if their residents spends less than this national average. Okay, again the keyword is average. It means the hypothesis test is about average. And another keyword, they want to know if this the mean is less than the national average, and the national average is 16,803. So we have 100 randomly selected residents, and they found that they spend 15,800 with a standard deviation of 2,600. And the question is there any evidence to state that on average residents of this community spends less than the national average of housing in 2011? So, and the question is about, or the hypothesis test about, the population mean, and we want to see if the population mean is less than 16,803. So step 1, we want to see if mu is less than 16,803 or mu is equal to 16,803. In step 2, we need to calculate the test statistics. The sample size is 100. From the sample, we have a sample mean. The sample means is 15,800 and the sample standard deviation. So we have S here, not sigma. So we have a standard deviation from a sample. So X bar is 15,800 and S is 2,600. So we have S and the sample size is large. So we have case 2. In case 2, the test statistics is Z X bar minus mu 0 S divided by N. So X bar is 15,800, mu 0 is 16,800, S is 2,600 and N is 100. So the test statistics value is minus 3.86. In step 3, we need to find a critical value from the normal table. Alpha is 0.05 or we can say 5%. Both of them are the same, 0.05 or 5%. So alpha is 0.05 and we have a left tail test, it means one tail test, so we need Z alpha. Z 0.05 is 1.645. In step 4, rejection region, we have a left tail test minus 645. Here is the rejection region and the test statistics is minus 3.8. So minus 3.8 is here. So the final decision is reject H0. Okay, exercise 4. A professor wants to know if her introductory statistics class has a good grasp of basic maths. 6 students are chosen at random from the class. The professor wants the class to be able to score above 70 on the test. The 6 students get scores of 62, 92, 75, 68, 83, and 95. Can the professor have 90% confidence that the mean score for the class on the test would be above 70? Okay, the first keyword is mean score. It means the hypothesis test is about the mean, and the other one is above 70. So we have a right tail test. So step 1, the hypothesis test is about mean. Mean is above 70 or is not above. For example, 70 is equal to 70, or you can write it is equal to 70 or less than 70. Both of them are correct. Step 2, we need to calculate the test statistics. The sample size is 6. Then we have a sample. It means you have 6 values in the question. So from these 6 values, you need to calculate sample mean and sample standard deviation or sample variance. So So for example, you need to calculate x bar from this, for example, 62 plus 92 plus, for example, 95 divided by 6, and x bar is 79.70. And also you need to calculate S, or sample standard deviation. You should use the calculator to obtain x bar and S. So x bar is 13.17. So the test statistics, sample size is small. We have S, it means the standard deviation from the sample. So we have case 3. In case 3, the test statistics is T equal to x bar minus mu 0 divided by S divided by a square root of n. X bar is 79.70 minus mu 0 is 17. S is 13.17 and n is 6. So the final answer is 1.7. In step 3, you need to obtain a critical value from the T table. We have a right tail test. For right tail test, if you look at the formula for right tail test, we need T alpha with 9 minus 1 degrees of freedom. So for this question, 90% confidence. It means confidence is 1 minus 90% confidence. It means 1 minus alpha is 0.9. So alpha is 0.1 and we need T with 0.1 and n minus 1. N is 6, so n minus 1 is 5. So we need T 0.1 with 5 degrees of freedom, and the value is 1.476. This is step 3. In step 4, we need to make a decision. We have a right tail test, so 1.476. This is the rejection region, and the test statistics is 1.7. So 1.7 is here, 1.7. So the result is reject H0. 5. Professor Hadley has a weakness for cream-filled donuts, but he believes that some bakeries are not properly filling the donuts. A sample of 24 donuts selected and reveals the sample standard deviation equal to 0.11 cups. test a 95% the null hypothesis that the population variance of donut filling is significantly different from 0.05. So the first keyword is population variance. So the null hypothesis is about, or the hypothesis is about population variance. So we have a hypothesis test for variance and is significantly different from 0.04. It means we have a two-tailed test. The population variance is equal to 0.0504 or is not equal to 0.04. So in this question, in step 1, we need to formulate H0 and HA. The hypothesis tests are about the population variance. If the population variance is equal to 0.04 or is not equal to 0.04, so we have a two-tailed test. In step 2, we have 24 donuts, so sample size is 24, and the sample standard deviation is 0.11. So the standard deviation from sample, it means S is 0.11. So the test statistics is the chi-square one. It's n minus 1 S2 divided by sigma 2. N minus 1 is 23. S2, it means 0.11 power 2. And sigma 2 is sigma 20. Sorry, it's 0.04. And the test statistics result is 6.96. Okay. If you look at the formula for a hypothesis test for population variance, for two-tailed test that we have in this question, the rejection region has this shape. So we need a chi-square for n minus 1 degrees of freedom, and with probability 1 minus alpha divided by 2, and again n minus 1 alpha divided by 2. So in this question, alpha is 95%. It means 95 confidence. So alpha is 0.05. So in step 3, one minus alpha is 0.95. So alpha is 0.05, and we need two critical values from chi-square table. One of them for alpha divided by 2, and another one for 1 minus divided by 2. So n minus 1 is 23, 0.025, and again 23, 0.975. If you check the chi-square table, the critical values are 38.076 and 11.689. So in step 4, the chi-square is the positive distribution, so it's better to use step 4. Okay, one of them is 11.689 and another one is 38. 11.689 and 38.076. So this is the rejection region, and test statistics is 6.96. So 6.96 is here, so the result is rejecting H0. A manufacturer of safety hard hats for construction workers is concerned about the mean and the variation of the forces its helmets transmits to wearers when subjected to a standard external force. The manufacturer desired the mean force transmitted by helmets to be 363 kg or less, well under the 454 kg limit. He also desired sigma to be less than 18. It is known that the force transmitted by the helmets is normally distributed. Tests were run on a random sample of 40 helmets, and the sample mean and the sample variance were found to be 374 and 1066. Part A. If mu is equal to 363 and sigma is 18, what is the probability that the helmet subjected to the standard external force will transmit a force to a wearer in excess of 454? So it's just a probability related to normal distribution. In fact, this part is not related to hypothesis test, but you need to calculate the probability of x greater than 454. So mu is 363 and sigma is 18. So we need to normalize this probability. So z is greater than 454 minus mu divided by sigma, it means 80. So it's the probability of z greater than 5.06. So it's 1 minus it's approximately 0. So the probability that the x greater than 454 kilogram is 0. So as they mentioned here, well under the 454 kilogram limit, so it is actually under the 454 kilogram. Part B. Does the data provide sufficient evidence to indicate that when subjected to the standard external force, the helmets transmit a mean force exceeding 363? So again, mean force, the hypothesis test is about mean, and another keyword is exceed. Exceeding, it means greater than. So we have a right tail test here. So in part B, HA H0 step 1 is mu is greater than 363 or mu equal to 363, or you can write it mu is less than or equal to 363. Both of them are correct. In step 2, we have n equal to 40. The sample size is 40. The sample mean is 374, and the sample variance is 1066. So we have n equal to 40, x bar equal to 374, and S2, the sample variance is 166. So we have sample size is large. Also in the question we have that according to the question we have the normal distribution here. So this one is case 2. So we need to calculate the z x bar minus mu 0 divided by s. This one is s2 divided by square root of n is 40. So the test statistics is 2.30. We have a right tail test. Here we don't have in the question, I think we don't have the level of the significant level of the test. Yes, we can assume that alpha is equal to, for example, 0.05. So in step 3 we assume alpha is 0.05. we have a right tail test. So z for alpha, it means that 0.05 is 1.645, so 645. So in step 4, rejection region is the right tail test is here, and the test statistics is 2.30. 2.30 is here, so the final decision is reject H0. And part C, does the data provide sufficient evidence to indicate that sigma exceeds 18? It means that in part C we have a hypothesis test for population variance, and so again we have a keyword exceed, so it means greater than 18. Sigma greater than 18, it means sigma 2 is greater than 18 power 2, and H0 is sigma 2 is less than or equal to 18 power 2. So 18 power 2 is 324. so we can write it as greater than 3 to 4, or sigma 2 is equal or less than 324. So in step 2, again n is equal to 40 and S2 is equal to 166. So we have a chi-square test statistics is n minus 1 S2 divided by sigma 0 power 2. N minus 1 is 39. S2 is 1066 and sigma 0 power 2 is 324. So the test statistics is 128.31. We have a right tail test. For right tail test, we need to alpha is 0.05, so we need a chi-square with n minus 1, it means 39, and alpha it means 0.05. If you look at this formula, you can see for a right tail test we need a chi-square n minus 1 and alpha. So it is approximately 55 because we don't have 39 in the chi-square test, so we can consider 40. It's 55.758. So step 4, this one was step 3. Rejection region, we have a right tail test. Chi-do is a positive distribution. It's better I remove it and plot it again. So right tail test, it means 55.758 and right tail is here, and the test statistics is 128. So 128.31 is here, so the result is rejecting H0. Okay, thank you so much.